What if I told you that something burning at 3,000 degrees Fahrenheit is silently carving through the sky above you right now, and most people never even look up to see it? Not a plane, not a satellite. Something far more ancient, far more violent, and far more beautiful than either of those things. We're talking about fireballs, and the glowing trails they leave behind could rewrite everything you thought you knew about what falls from space. Let's start with the basics, because this is where most people get it completely wrong. A fireball is not just a shooting star. When most people hear shooting star, they picture a quick little streak of light, and that's it, gone in a second. But a fireball, officially classified by the American Meteor Society as any meteor brighter than magnitude -4, is something on a completely different level. That's brighter than the planet Venus in the night sky. We're talking about an object that can light up an entire landscape like a flash of lightning. But instead of disappearing in a millisecond, it keeps going, keeps burning, and keeps moving across the sky for several terrifying and breathtaking seconds. Now here's where it gets controversial, and where scientists themselves are still debating the full picture. When a fireball blazes through Earth's atmosphere, it doesn't just disappear cleanly. It leaves behind something called a persistent train, sometimes also referred to as a meteor train or a persistent meteor trail. This glowing trail can hang in the sky for anywhere from a few seconds to, and this is where people genuinely don't believe it, several minutes. There are documented cases where these trails lasted over 30 minutes. 30 minutes of a glowing, twisting, color-changing cloud lingering at altitudes between 50 and 100 kilometers above Earth's surface. And here's the part that breaks people's brains. Scientists are still not in complete agreement about exactly what makes these trails glow for so long. There are competing theories. The dominant explanation involves a process called chemiluminescence, where the molecules in the atmosphere that were chemically altered by the meteor's extreme heat continue to release energy as light. But some researchers argue that the complexity of what we observe doesn't fully match that explanation alone. There's also the involvement of metal atoms, things like sodium, magnesium, and iron, that are vaporized off the surface of the incoming rock and then interact with atmospheric oxygen to produce different colored glows. That's why these trails sometimes shift from green to red to orange to white as they evolve. You're watching real-time chemistry happening at the edge of space with your naked eye. According to NASA's Center for Near-Earth Object Studies, Earth is hit by about 48.5 tons of meteoritic material every single day. Most of it burns up completely and goes unnoticed. But fireballs, the big, dramatic ones, are tracked by a worldwide network called the American Meteor Society Fireball Network, and the reports are staggering. In 2023 alone, tens of thousands of fireball events were reported by observers across North America. And that's just the ones people actually saw and bothered to report. The real number is believed to be significantly higher because most of Earth's surface is ocean, and most of the sky is unwatched at any given moment. Here's the controversy that the mainstream conversation tends to gloss over. Some of these persistent trails have been photographed twisting and curling in ways that early researchers initially could not explain through simple atmospheric wind patterns alone. Trails photographed after significant fireball events have shown what scientists describe as billow structures, complex swirling formations that look almost organic. The 2013 Chelyabinsk meteor event in Russia, which injured over 1,600 people and generated more energy than a nuclear bomb upon atmospheric entry, left behind a persistent trail that was photographed stretching over 500 kilometers across the sky. That trail remained visible for over 30 minutes and was observed twisting dramatically due to high-altitude wind shear. Scientists used it to study upper atmosphere wind patterns in ways that were simply not possible before. The temperature of a fireball during peak atmospheric entry can reach between 3,000 and 10,000 degrees Fahrenheit. For context, the surface of the sun runs at approximately 10,000 degrees Fahrenheit. Some of the largest and fastest fireballs are briefly reaching temperatures that rival stellar surface conditions, right here in our own sky, and we're walking around completely unaware. And this is where I need you to stop and actually think about the scale of what this means. Every night, every single night without exception, this is happening somewhere above you. Objects that have been traveling through space for millions, sometimes billions of years, making their first and only contact with Earth's atmosphere, burning up in seconds, and leaving glowing chemical signatures hanging in the upper atmosphere, like signatures from the ancient solar system itself. These trails are literally made of materials older than Earth, older than the oceans, older than any living thing that has ever existed on this planet. The next time there's a major meteor shower, the Perseids peak every August, the Leonids peak every November, and the Geminids peak every December, go outside and actually watch. Don't watch from inside. Don't glance through a window. Lie on the ground, face up, eyes fully adjusted to the dark, and give it at least 45 minutes. The American Meteor Society recommends that minimum because your eyes need 20 to 30 minutes just to fully dark adapt. If you're patient, if you're lucky, you might see a fireball. And if that fireball leaves a persistent train, a glowing twisted ribbon of ancient chemistry hanging against the stars, you will never again look at the sky the same way. Follow this page right now because we are just getting started on what the universe is quietly doing around you every single day. So here's what I want to know. Have you ever seen a fireball in real life? And if you have, did it leave a trail behind that you couldn't explain?